Hey Algebra 2 students, today we're going to be talking about writing piecewise from a graph. So essentially working backwards from what we've been doing. Please make sure that you're taking notes somewhere. Pause the video when you need to and make sure you're asking questions if you have any while you're watching. So our first step when writing piecewise from a graph is to determine our domain. For each piece of the graph. Get it? Piecewise. And if you need to, go ahead and refer back to our domain and range notes if you're struggling with that aspect of this problem. The second step after we determine our domain, we're going to determine the slope and a point on the line for each. So again, just like domain, we're doing this for each piece of our graph. Once we have a slope and a point, our third step is we're going to write an equation in point-slope form. So if you guys will recall from when we reviewed linear, point-slope form looks like y minus y1 equals m, parentheses x minus x1, where m is my slope that we'll be replacing, and y1 and x1 represent the points from our slope, the points from our point, sorry. Once we've done that, the fourth and final step is to convert our point-slope equation to slope-intercept form. And write it all together as a piecewise function. So let's go ahead and take a look at an example of how we would do this. Again, pause the video if you need to write this graph on yours so that you can follow along as we're going. So recall our first step is to determine the domain. So for each of these pieces, I'm going to determine my domain. So I noticed here on the very left of my graph, it goes off the grid, which is like having an arrow here, which tells me I'm going from negative infinity on the left, and then on the right, it stops at an x value of -3. Then we need to think about, is it equal to or not? So remember that anytime we have infinity, it's not equal to. And then here, because we have a closed dot at -3, it will be equal to. For our green line, on the very left, I see it starts at an x value of -3. On the very right, it stops at an x value of 2. And again, open dot means no equal to, closed dot means equal to. And our last line here, on the left, I see it starts at an x value of 2. And then here it goes off my grid, which implies that it's going forever and ever towards infinity. And then because we have an open dot here, this will not be equal to, and because we have infinity, it will be not equal to. So there's our 3 domains, and we're done with step 1. Step 2, determine the slope and a point for each line. So our red line here, remember slope means rise over run, so I'm going to look between 2 points, and I notice it rises 2 and goes over 1. So my slope is 2 over 1, which is the same as 2. Then we need to pick any point on this line. So I could choose this point here, or I could choose our endpoint. I'm going to go ahead and use the endpoint. So that's the x of -3, and our y is 0. For our green line, my slope, the rise here doesn't rise at all, which tells me I have a rise of 0, and 0 divided by any number is 0, so my slope here is 0 since it's a flat line. A point here, we can choose any point on this line. I'm going to go ahead and choose this end point here, so the point 2, 2. And last, our black line here. My rise is 1 and my run is 2. So if I write that out, that's a slope of 1/2, which is equivalent to 1/2. Then I can choose any point on this line. I'm going to go ahead and use this end point here. Even though it's an open dot, it still can be used to write our equation. So this is the point 2, -3. Okay, once we've done this, we've determined our slope and points, we can go ahead and write the point slope form of the equation. So remember, that's y minus y1 equals m parentheses x minus x1. So with our red equation here, I'm going to fill in where I see m, x1, and y1. So this is going to become y minus, then our y value in this problem was 0, so I'm going to plug that in. Our m was 2. And my x value is a -3. And remember, when I plug in a -3, when there's always already the subtraction, I'm going to end up with 2 negatives, which makes a positive. For our green one, I got y minus. My y value here is 2. My slope is 0. X minus, and my x value is 2. And finally, our black line, we got y minus. My y value here is a -3, so this is just like earlier, a negative and a negative will make that positive. My slope is 1/2, and x minus, and my x value is 2. We are now at our final step, step 4, where we're going to convert these to point to slope intercept form. So anytime I see a number outside of parentheses, we can distribute. So for this red one, I'm going to multiply 2 times both of these. 2 times x makes 2x. 2 times 3 makes 6. And then y minus 0 is just y. So we are done converting to slope intercept. For this problem here, I have y minus 2 on this side. And 0 times all of these things is just going to be 0. Then to convert it to slope intercept form, I need to get y by itself, so I'm going to add 2 to both sides. So we end up with just the equation y equals 2, which if you remember is that flat line, so it makes sense that we have no x value for that problem. And last we have our black one. 1/2 times x minus 2. 1/2 times x makes 1/2 x. And then 1/2 times -2 is just a fancy way of saying what's half of 2, which we know is 1. We still need to get the y by itself, so the inverse of adding 3 is subtracting. And we end up with y equals 1/2 x minus 4. And then that final step, step 4, also has us writing it all together. So let's take a look at how we would do that. I have all of my information here, and I'm going to write it as y equals all of this stuff. Writing little bracket things is fun. And we're going to start with the line to the very left. So the equation that we wrote is y equals 2x plus 6. But note, we already have the y equals here, so we're only going to write the 2x plus 6. And then next to that will go our domain. So we had the domain of -∞, x is less than -3. The next line moving to our right is the green one. So my equation that we wrote is y equals 2, and we already have the y equals chart, so we're just going to write 2. And then our domain was -3 to 2. Last but not least, our black line, we had y equals 1/2 x minus 4. We already have the y, so we just write 1/2 x minus 4. And our domain was 2, to infinity. And this is our final piecewise function. Thanks for watching. If you guys watch this video in all of its entirety, please in the comments for this video, leave a comment with the code word done.